I was telling you guys about differential equations. If you major in math or in engineering or possibly other subjects, but definitely those two, most of the time you're required to take an entire class on differential equations. And I was telling you guys that I didn't take that one because they had the schedule kind of strange at Meredith. But we are going to do sort of the beginning of what would be in that course. You would start with slope fields like we did. So now we are going to look at solving differential equations. So number one is a differential equation that we have really already done. Because we would just multiply both sides by dx, which a lot of times when we were doing these problems, we didn't even really write this step right here. So what we have done whenever we do this is we have separated our variables. We have all of our y's on the left-hand side, and we have all of our x's on the right-hand side. Daniel, why don't you put that phone away for me, please? Thank you. All right, so we integrate both sides, and so y would equal. Over here, we're just integrating. So, Logan, when we integrate 2x plus 5, what will we get?
Wait, oh, we're integrating.
Sorry,
we're going to get but,
yeah. Increase your exponent. Yeah. Yeah. Something else on the end plus c on the end. Okay? All right, so this is your most basic type of differential equation that you'll see. It's basically just integrating. But in order to solve this, you must separate the variables. All x's must be on one side, all y's must be on the other. And your dx and your dy need to be in the numerator. You should not have them in the denominator. So let's look at one that is more difficult to do. Okay, so y prime equals 2x over y. I specifically use this notation right here because they use it in your textbook some, and you may even see it on the AP exam. But in general, if you see y prime is the same as dy dx. So to solve a differential equation, you really need the dy dx notation so that you can separate variables. So I'm going to change this to dy dx equals 2x over y. So if you see the y prime notation, you want to replace that for these problems. All right, so we need to get all of the x's on one side and the y's on the other. So in this case, we can do that really easily by just cross multiplying, because on our diagonals we have all of our y's, the other diagonal we have our x's. So we can do y times dy equals 2x dx. If it's two fractions equal to each other, you can always cross multiply for those. As long as, if you had a plus 3 over here on the end, you could not do it because it wouldn't be just two fractions equal to each other. Sometimes it's helpful to do, sometimes it's not helpful in these problems, we'll see. But in this case, because all of your y's were here and all of your x's were here, it was helpful. Okay, so the first step on these is always to separate your variables, because if your variables are not separated, then you can't solve any further from there. So then, when you're asked to solve the differential equation, this dy dx is our derivative. To solve a differential equation, you're looking for the antiderivative of that. You're wanting to get an equation where you have y equals something. So we need to integrate, which will get rid of the dy and the dx. I've been telling you guys that the dy and the dx were important. Many of you have ignored my pleas for you to put the dy in, well, we haven't seen dy's, but we've seen dx's. Many of you have not written those down. They are extremely important, especially on these, because if you don't have that dy or dx, they're not going to count your variables as separated and not going to give you credit for really much of anything on these. And a lot of times there's a free response question about this, and a lot of times solving the differential equation is worth like 5 points on that part of the free response. So if you don't separate your variables right, then you can't get any points on it. So you definitely don't want to mess that part up. So when we integrate both sides, we're just integrating the y, so it has an exponent of 1. So Thomas, what do we get when we integrate y? No. No. Raise your exponent by 1. 1/2 y squared plus c. And I'm going to put a little 1 back here behind the c, because what's going to happen on the other side? I'm going to get another c. All right. We don't want to use, that's why I want to put a 1 and a 2, because we don't want them to cancel each other out. And I'm going to show you a shortcut where we don't have to do that every time in a second. All right, Ethan? Almost. What else do we need with it? No. You're good on that part. X squared is that plus c, and I'm going to put me a little 2 right here. Okay? So, let's talk about the plus C1 and C2 for a second. We're not going to have to do that every time because C represents an unknown value, correct? We don't know what it is. So if I take this, if I subtract C1 over here, I'll get 1/2 y squared equals x squared. If I have an unknown value and I subtract an unknown value, I still get an unknown value, right? So I'm going to, if I want to be really precise, I can say let C equal C2 minus C1 and just put a single plus C over here on the side. So an unknown value minus another unknown value still gives you an unknown value, which I'm calling plus C. We're not actually going to do this every single time. I'm going to show you a shortcut so that you don't have to do that every time on the next problem.
It could be plus minus C or anything.
Yeah, you can put plus C minus C. Yeah, it doesn't really matter. You don't want to do crazy stuff like C squared because then it could never be negative. I'm going to show you a shortcut so that you don't have to do that every time. Yeah. So I wanted to show you where you technically have a C. Like when you integrate each side, you technically should have a C on either side. But those can be combined, which we're just going to call this C. So on our future problems, we are just going to use the plus C on one side. Is what we're going to do essentially. So depending on how they want you to leave your answer, they may leave the answer like this right here. Sometimes they will say something like, give your answer, how to say it, in the form y equals f of x. If they say something like this, this right here means solve for y. So usually these are worth, if they're on free response, they're usually worth like 5 or 6 points for this part of the free response. So if you got to here but you did not solve for y and it had asked you to, you would probably lose one of those 5 points on that. So it wouldn't cause you to miss everything. But if you see this, give your answer in the form y equals f of x, something like this. That means solve for y, get y by itself. So if they asked you to do that, you could multiply both sides by 2. So you get y squared equals 2x squared plus c. Do I have to multiply the c by 2? I could if I wanted to, but I don't have to because c is an unknown value and it's still, 2c is also still an unknown value. And then I would square root both sides. So y would equal plus or minus the square root of 2x squared plus c. That's a good question. I don't think so, because I think if it is on the outside, it would change what it would look like, because numbers on the inside move things left or right, whereas outside would be up or down, and there's not always an equivalent there. So I think we would just want to keep it on the inside for that. Okay, so that would be our solution to our differential equation. You could, if you had a slope field, you could graph what these look like here. Okay, questions? Okay, so these problems we're actually not going to solve. We just need to be able to tell whether they are separable or not, meaning that you can separate the variables. So, first of all, for these, I think I've made a mistake. Notice the variables are different. I've got dy and dt instead of dy and dx, except for over here I really meant for this to be a t instead of an x. So, okay, so for A, if I tried to separate here, I would need to multiply both sides by dt because you can't have the dt in the denominator. So I've got dy equals y plus t dt. I mean, what you want to do is you want to subtract that y, but you can't do that unless you distribute the dt first. So dy would be y dt plus t dt. So if you did move the y over, it'd have that dt with it. And so, if you do that, it's not really going to work because we're going to have y dt equals t dt. So you might think, I could divide by dt. But there's a minus. So if you did that, you'd have to divide this by dt, which you'd still have a t on this side. So this one is going to be a no. It's not separable. So all of my work there was in vain. It cannot be separated. In general, you're going to see that's the case whenever you have that plus or minus, in a lot of cases anyway. So that one cannot be separated. This does not mean that you will not see these on the exam. It just means they will not ask you to solve these on the exam. So they could still give you a slope field that has something like this that's not separable, because for slope fields, all you got to be able to do is plug in the numbers. They probably use x and y instead of t and y, but they could give you a slope field. They could even give you something like this and then ask you maybe a tangent line problem, because you could just plug numbers into that. So they could ask you things about a problem that's not separable, but they will not ask you to solve a problem that's not separable. Because you can't. I mean, I think there are some ways, but I never took differential equations, so I don't know what they are. Yeah, we'll just call him up. Let's get him to explain. I'm sure he remembers it all. So what about B? Can we separate B? Okay. What would we do to separate it? Okay. We'll multiply dt. So we'll get dy equals ty over t plus 1 dt. Okay. I still have this y on the side. How do I get rid of it? You could do it that way. You can, but it is okay on this one. You can do it that way. But it is okay on this one just to like divide by y or multiply by 1 over y. Because up in this numerator right here, you have t times y, so it will cancel with that y right there. So it is perfectly fine to do it that way where you like multiply and then divide and then bring that t plus 1 back, but you don't have to. So you could just divide that y there, and so you would end up with 1 over y dy equals t over t plus 1 dt. Yes. So the question's not multiple choice. It's not multiple choice. So B is separable. A is not separable. Is C separable?
It probably is. I'm gonna say yes. It's probably like you can take all apart. Let's see. I'm gonna say no.
T's and Y's. So like on this one, we were able to separate it because everything over here had a Y and everything over here had a T. All right, so I taught this one for 2 or 3 years and said it was not separable, but I was wrong. You can separate it. All right, because E, let's just think of it this, it's this property of exponent or of exponents that matters. If I do x squared times x to the third, what do I get? X to the fifth, because I did x to the 2 plus 3. So that means if I go backwards, that means I can write this as e to the t times e to the y. Now it should be pretty simple to do. Multiply by dt. That gets the dt over here. That's a step you're going to do about every time. Okay? And then notice here, everything's multiplied together. Right? We got e to the t, e to the y, and dt. All 3 of those things are multiplied together. So how could we get rid of that e to the y? Divide it off. So we could divide by e to the y here, which will cancel it out, and divide by e to the y here. So you'd probably write this, you could write it as dy over e to the y, or you could use negative exponents if you want there, and it equals e to the t dt. So everything on the left-hand side has the y's, everything on the right-hand side has the t's. So that one is separable. I don't think you'll see that. I don't think you'll see it. Our textbook doesn't put really this in here much, but it is separable. Okay, questions? Good. All right. Let's look at example 4. Good. All right. You are going to do a little math. I can't risk losing my title as homework. Not letting that go. I know, but if word gets out that I didn't give any homework over spring break, what's going to happen to my chances next year? All right. So It's a short assignment. All right, multiply both sides by dt. Daniel, I'm not going back over this on Monday, so I'm hoping you're soaking it all in. Maybe so. Maybe so, but you usually look a little more attentive than you do today. You usually work out the problems, though. You usually don't look on your phone. Okay. Yeah, calculus doesn't work that way. I've taught some really smart kids. And I've not had kids that can just, like, teach themselves how to solve a differential equation without ever seeing anybody else solve a differential equation. Now, they might be able to go a little bit further. Okay. You're exactly right. Y squared. So this is really the most important part right here. They do not cancel. You can't. dy is like you got to think of dy as like a different variable than the y. So you cannot cancel it. So don't think of that as d times y. It's different than. Okay? All right. All right, so since we have separated, all of our y's are on one side, all of our t's are on the other, we now can integrate. Okay, now I would like to over here think of this as y to the negative 2 dy whenever I'm integrating. So here's my little thought bubble. This is how I'm going to think of it. Yeah, please do. They'll like it. All right, so y, we're going to raise the exponent by 1, which is going to be a negative 1. We're going to divide out front by that negative 1, which is going to make that negative y to the negative 1. I'm not going to put a plus c here, which is okay as long as I put it on the other side and I'm integrating both sides at the same time. Okay? Yes, that's the shortcut that we're going to use. Yeah, so all right, so this is important. Okay, if you use this shortcut where you don't write the C1 and the C2, then you have to integrate both sides at the same time. So you cannot integrate this side and then 3 or 4 steps later integrate the other side. Because as soon as you integrate, there must be a plus C. So you want to integrate both sides at the same time in order to not have to do the mess that I did last time with the C1 and the C2. Here you do have to do like a tiny u/du substitution here. It's teeny tiny because u would be negative t, which means du would be just negative dt. And you do not have a negative with that dt, so you have to put a negative on the inside and also a negative on the outside. You can do this part in your head, it's okay. If you do it in your head and don't write out the substitution part, that'd be fine. No. It will work the same way on this one because it's just a negative. But like if that was a 2t, you would get 1/2 e to the 2t instead of getting 2 times e to the 2. For it just to be itself. Yeah, you have to do like a tiny little u/du substitution. Yeah. So we're going to get, when we integrate the e to the u, we get that same thing again. So we're just going to get negative e to the negative t there. If you don't do that little tiny u substitution, you won't have that negative that was out here. And we will put the plus c right here. Yes, if it was just If it was just e to the t, we would just do e to the t.
And we can divide the negative ones away on both sides.
We could. So we would get y to the negative 1 equals e to the negative t plus c. If they do not ask you to give it as y equals, then you really could have stopped here if they don't ask you to solve it for y equals. But if they ask you to solve it for y, I'm going to think about e to the negative 1 as 1 over y. Multiply both sides by y, because we cannot solve for this whenever y is in the denominator. So I've got 1 equals y times e to the negative t plus c. And then you're going to divide by the e to the negative t plus c. So your y would equal 1 over e to the negative t plus c. You don't want to because of the plus c. It will not become minus c. That's negative exponents only. You could, well, you can't split it. You can't, because if you did split them up, it'd be like doing the love connection upside down, and we can't do the love connection upside down. Okay. All right. All right, last one. All right, notice this one gives you the y prime. So we want to change it to a dy dx. And we'll go ahead at the same time, that'll be a good idea, and move that 3xy over to the other side. All right. What do you think? What should we try?
Let's multiply the dx.
Okay. We do pretty much always want to multiply by the dx because we can't have that dx in the denominator, so that's not a bad strategy there. You can do it at the same time, or you can do it first, however you would prefer but we got to get rid of this 1 plus x squared because the y's are supposed to go on that left-hand side. So you could do it as the same step, or the order of the steps necessarily are not so important here because you're just multiplying and dividing. Yeah. So we got dy equals negative 3xy over 1 plus x squared. The dx, we can put it in the numerator or we can leave it out to the side. Either one is fine. As long as it's not in the denominator, you can't have it in the denominator. So we're almost there, but we've still got a y over here. We can multiply by 1 over y, and because all of that stuff in the numerator is multiplied together, we can cancel that y, which means we'd also multiply over here by 1 over y, like this. So we get 1. We get 1 over y dy. Remember, you cannot put dy and y together. They're separate variables. You could, if you would like, you can write it like this, dy over y, or you can write it as 1 over y dy, whichever you prefer. Okay, so once we have everything completed, we're going to integrate both sides. Now, the left-hand side is a simple integral, if you remember what the integral of 1 over y is. It's natural log. But here is the warning that I want to give you. You don't want to integrate it yet. Because I told you that if you're going to combine the plus c's together, then you need to integrate them in the same step. And the right-hand side is not going to be quite as quick to integrate. Because the right-hand side, what are we going to have to do to integrate it? U substitution. So I am not going to integrate that left-hand side until I'm also ready to integrate the right-hand side. So the u is going to be our denominator, 1 plus x squared. What is du? 2x. dx, write that with it. Okay. So that 3x is, that negative 3 is in our way, so I'm going to pull the negative 3 out. And I also need a 2, so I'm going to add a 2 in there with my x, which means I've got to put a 1/2 out front. Right. Yes, negative 3 over 2. Good. So I'm not going to integrate this yet. I'm going to leave it 1 over y dy for the c purposes. And then I'm going to rewrite this with the u, so it's going to be negative 3/2 integral of, it's going to be 1 over u du, or if you want to write that as, du over u, that's also okay. We okay here?
The one on the quiz was u substitution. That one right there, 2c.
I can't remember.
It was like on a, it was a fraction.
I can't remember. I think it was, no, it was a derivative. I think it was question rule.
Yeah, that's okay.
Yeah. All right. Okay. So now at this point we can integrate both sides. So now you would get your natural log of e. I'm sorry, not e. Sorry. Natural log of y. I don't know, I put that e in there. Natural log of y. Actually, absolute value of y equals negative 3/2 times the natural log of the absolute value of 1 plus x squared. And we're going to put the plus c over here. I went ahead and plugged my u back in at that point. If you wanted to put the u there, you could. That's fine. And then you'll have one more step where you have this. Okay, a question real quick. Are the absolute value bars necessary over here?
No, because it has that, because it can only be positive.
This can only be positive. They are still necessary over here.
Would they count wrong if you just keep it?
I don't think they'll count it wrong. So if they didn't ask you to solve for y, you would be done here because you have x's and y's and you don't have any dy's or dx's anymore. But a lot of times they'll ask you to solve for y. So there's a couple things that they're going to do here if they ask you to do this. This gets a little bit messy. So I want to get rid of a natural log, I would do e to the power. But if I do e to the power over here, I've got something on the outside. So how could I...
Just omit it for a moment.
No, you cannot.
Log
Log rules tell us that goes in as an exponential. So let's actually not get rid of this quite yet. Let's write this as... Okay. Okay. It is over here for the e for right now. Over here, you can keep it or not because 1 plus x squared is always positive. Okay? All right. Okay. All right, so our properties of logs tell us that if we have a coefficient, we can pull it in as an exponent. So now, whenever we do e to the power, okay, that's the problem. So this seems complicated, what I'm going to explain now, but it's not as bad as it it's going to become pretty easy as we do more of these problems. All right, so over here, this is going to cancel. We got absolute value of y. All right, so we're going to use that same property I just did when I had e to the x plus y, and I wrote it as e to the x, e to the y. So I can write this as e to the natural log of 1 plus x squared negative 3/2 times e to the c. And so since I've separated these now and there's not that plus sign, now the e and the natural log can cancel here. And e to the c is e to an unknown number, which is still just an unknown number, right? So I'm just going to call it c. I guess technically maybe I should have that 1 if I'm writing this higher. You don't have to do that. So we can write this as c. It's not going to be if it's on multiple choice and they put these on there. So and we're going to do several of these. What you're going to see is every time you do this e right here, it's going to come out front as a big C. You don't have to explain why you did that. So whenever you have the e that you're raising to both sides, you don't have to explain why you did it. So you don't have to write this step right here. You can just automatically pull that out front as a capital C. Okay. So now I do still have absolute value bars here, which means that with absolute value we could write it as a plus or a minus. So we could write it like this, plus or minus c 1 plus x squared negative 3/2. But c is an unknown number. It can already be positive or negative, right? So we could just put y equals c times 1 plus x squared negative 3/2. Yes. They might write it as a root or move that negative exponent to the bottom. They can do all those things.
And the root would just be like.
I love problems like this. I like to look at the whole problem. Yeah. I'm not sure about the answer to that, Laura. I'm not sure. If it won't, I think it may let you do it tomorrow, but I'm not certain about that. So, yes. Yes, I'm going to try to grade before I go because I just want to have that done before I leave. So, yes, I'll grade yours first.
I'm going to stay.
Yeah.
I really want to do good on the midterm.
Yeah. Yeah.
So you get Shrek, you are required legally to be Shrek. Due to the contract.
All right. So, homework is page 382, 1 through 8, in case you did not see it there.
Yeah, I'm gonna wait till Sunday night.
It might not be a bad. It may not be a bad idea to do that, so it'll be fresh on your mind before class Monday. And don't forget Pi Day is Monday.
How many
So,
after that FRQ 17?
I forgot to ask if we're allowed to do that or not. I know we can't have homemade stuff. I've not given you official permission to bring pie items. I've not done that, in case I wasn't supposed to. Does everybody understand what I'm saying there? Okay. Yes.
My face hurts so bad.
Your face?
Smiling all period. I don't know why. And I'm okay with that.
I was looking at him, he was just creeping me out. What?
Sometimes that happens to me. just threw in math. So let it separate.
No, I mean, it's just been like 2 periods now.
Yeah.
I'm just very happy.
Good.
I was saying that she used to call us. Yeah, we get her killed.
Are you have you got your parts? Are you
No,
going?
but there's. I mean, it's possible that it could happen.
She used to call you Shrek and no?
Yes.
That's funny.
But you back in always wearing a green sweatshirt. And I would never shut up.
Huh?
I would never shut up, but you'd always wear a green sweatshirt.
That makes sense.
Yeah, 3:15. So we're gonna wait. We can
Oh,
go
it's
to
going.
the party.
No, I'm leaving. I'm going to my car.
I'm going to we shall spectate in Thomas's Audi. Yeah, everybody in the Audi. Everybody getting in Thomas's car. At least 10 people are about to get in your car.
I will keep it locked.
That thing will. Tommy, it has to unlock it somewhere.
It does.
Hey, that's cheap cool.
We need a pass calculus.
Let me